Okay, we are doing, what is this, 5.4 part 1, page 2. So we're still on part 1, page 2. So now we're going to look at condensing sums. So again, we're going to be using the sum and difference equations to help us out with this. But in condensing sums, we're going to find two angles that subtract to your third angle. I'm going to cross out this subtract. Let's just say find two angles that condense to your third angle. It's not always subtracting. We'll see where we can add and combine, condense the sums into one angle. So for the example, 5 pi over 3 minus 7 pi over 6, get a lowest common denominator, make the subtraction, then reduce it, and that becomes pi over 2. This example they have is kind of a silly one because it doesn't even have angles, but wants us to find the equivalent trig function of a single angle by using the sum or difference patterns. So you notice this is cosine, cosine on one side, sine, and sine on the other side. So that tells us we're going to use the cosine pattern. And since this is a negative sign, this is going to be cosine of u plus v. Okay, so again, if we can learn our sum and difference patterns, equations, then we can identify that. So in this case, this we'll call the u is 2 and the v is 4. So this would be the cosine of 2 plus 4, which gives us cosine of 6. So again, this is kind of a weird example. It's just trying to show you sort of the setup of it, how we take this this equation here and this pattern equation, and we rewrite it as that sum or difference equation. All right, so find the equivalent trig function of a single angle by using the sum or difference patterns. Here we have sine and cosine on one side of either our plus or minus, and then we have sine, cosine on the other side. So that tells us that we're dealing with one of the sine equations. And since this is a plus, we know this is u plus v. So we would do sine of pi over 3 plus pi over 6. And let's see, that would be then the sine of 2 pi over 6 plus pi over 6. That gives us the sine of 3 pi over 6. That gives us the sine of pi over 2. And the sine of the angle pi over 2 is 1. All right, pretty clean. Come over here to tangent. So this one's obviously, this is the tangent equation. It's going to be the tangent difference of 2. So this would be tangent of u minus v. And I know that because of that negative right there. So I'm going to tangent of pi over 7 minus pi over 21. Get a lowest common denominator, which would be 21. So this is 3 pi over 21 minus pi over 21. So this is the tangent of 2 pi over 21. And put a box around it. All right. So again, all of this comes down to knowing, these formulas. Okay, so let's go back up here. Okay, so now we're going to do sort of the same thing. We're going to use ratios. So we're going to have to find the third side of a triangle using the Pythagorean theorem. And I'm going to also suggest, it doesn't say it on here, but draw triangles. Okay, it really, really does help to take that time and draw a correct triangle. Okay, so let's look at this problem right here. And okay, sine, by the way, these are both positive. This is going to be a first quadrant. And so this is, we're going to call this u. So this triangle represents the angle u, and it's a sine, so it is opposite 3 over hypotenuse 5. It's a special right triangle. We know this is 4. If you don't believe me, you can use the Pythagorean theorem and figure that out. Okay, now we're going to come over here, and we're going to do a triangle to represent the angle V. In this case, it's cosine, so it is adjacent over hypotenuse. And again, this is a special triangle, so this is 5. Now that I have all three, I can use that to create the different ratios needed. So it wants me to find the sine of u minus v. Sine of u minus v is sine of u cosine of v minus sine of v cosine of u. All right, so, and again, just to remind ourselves, this is u. In orange and in green we have v. So we have orange, orange, green, green. All right, so sine of u would be opposite 3 over hypotenuse 5 times the cosine of v, which would be adjacent 12 over hypotenuse 13, minus the sine of v, which is, the sine is 5 over 13 times the cosine of u, which is 4 over 5. So you go 3 times 12 is 36. 5 times 13 is 65, I believe, minus 20 over 65. So 36 minus 20 is 16, so 16 65ths. All right. So that's how we use ratios and triangles. So we'll come up here, and I think there's just 2 problems. We'll knock these out real quick. Now, this is quadrant 4. So let's draw correct triangles. So for u, again, I'm in quadrant 4, so it's coming down here. My hypotenuse is here. This is u. Do the same thing here. I'm not concerning myself with the length of the sides. I'm not trying to keep that necessarily proportional. It's more that I have the positive and negative values. So sine, this is 5 is hypotenuse. Sine is opposite. This is negative 3. And then this side would be 4. And again, that's because it's a special right triangle. If you don't believe me, use the Pythagorean theorem. And here we have a hypotenuse of 13. And this is cosine, so this is 12. And this is negative 5. Now that I have all 3 of my values for each triangle, I can then set up my equation. So tangent of u plus v is tangent of u plus tangent of v over 1 minus tangent u times tangent v. Okay, so let's plug those values in. Tangent of u is going to be opposite negative 3 over 4 plus the tangent of v, which is going to be opposite negative 5 over 12 adjacent. All of that is going to be 1 minus negative 3 over 4 times negative 5 over 12. Okay, let's see. Lowest common denominator is 12, so that gives me negative 9 twelfths plus negative 5 twelfths. Down here I have 1 minus, negative 3 times negative 5 is 15. 4 times 28, or 4 times 12 is 48. That's going to give me negative 14 over 12. All of that, I'm going to figure out this right, is 48 eighths minus 15 48ths. Okay, let's just write this down here. Negative 14 over 12, 33 over 48. Okay, last little step, negative 14 twelfths times 48 over 33. Remember, this is, we're dividing here, which means we multiply by the reciprocal of this value. And let's see, that, I can cancel that out to be 4. and this is negative 56 over 33. Okay, so you got to bring back in your basic math there. All right, so for number 2 here, cosine of u minus v, cosine of u times cosine of v plus, again, it's always the opposite of that when doing cosine, sine of u, sine of v. So let's go cosine of u is 4/5 times the sine of v, which is 12/13, plus the sine of u, which would be negative 3/5 times sine of v, which would be negative 5/13. Let's see, this would give us 48, and what is that, 65ths? And this is going to be plus a, let's see, negative and a negative is a positive. Oh yeah, that's right. This is our 15 over 65. So that's going to be, I just right? I might have made a mistake in the math somewhere, but I'm recording, so I'm just going to leave it. 3, 4, 5, 6. No, maybe that's right. 63/65. Okay. I'll box it. Hopefully I got it right. If I didn't, I'll get a point off. But you got the gist of it, whether I got my multiplication right or not. All right. That's it.